Hi, my name is Joe Pilastri, co-founder and CTO here at Sentilla. Today we're going to be talking about how much energy a server actually consumes, and more specifically, how much energy the server consumes while it's doing different functions, such as running different applications, using its hard disks, or even running the fans. And the way we'll do that is through the Sentilla Energy Manager. So what I have in front of me today is a device which measures, monitors, and analyzes electricity use, part of the Sentilla Energy Manager. And we're going to plug our Sunfire server directly into this in order to better understand in real time how much energy it's consuming. This Sentilla Energy Manager sends and receives data wirelessly over to a web page here where you can actually see exactly what's going on. So what we'll do is we'll start off by plugging our Sun server in and looking at its consumption in the various different roles that it takes on throughout the number of applications that it runs. So here we plug in our server. And our server gets ready by turning on some of the power supply fans, but it's not yet actually running. What I can then do is turn on the server and let it go through its boot up procedure. You hear that now the server is fully active, and it's actually running the boot up procedure, and in a few seconds we'll be able to run some applications on it and profile the power consumption of the server and better understand what we can do to reduce our energy.
Now that we've turned our server on, we can see that it's consuming about 247 watts. We can run an application that maxes out the CPU by burning it in. And by looking at top, we can see that one of the CPUs is using 100%, but the whole system is only using 25%, or one of the cores. Accordingly, the power jumps up to almost 275 watts when we max out that core. But now we can also run 3 more instances of this application in order to max out all 4 cores of our server. When we do that and we look at top, we can see we have 4 processes at 100% CPU and that the CPU is now maxed out. Accordingly, the energy jumps as well, almost 350 watts. But it's not just the CPU that consumes energy. We can also look at the impact of the disks. With the Linux stress tool, we can thrash the disk with some worker threads. Correspondingly, the disk consumption increases initially pretty dramatically, but over time reduces and stabilizes at about 6 watts above the idle power consumption. Mechanical parts also have an impact on a server's power consumption. By removing a fan, we can actually see that this event occurred through the Energy Manager. As you can see, the power consumption is reduced by about 8 watts. If I put the fans back in, the system is actually going to check and make sure that all the fans are still running. When it does this, the power consumption increases dramatically by about 60 watts to check that all the fans are working properly. By performing all these operations, you can see that we've constructed a power profile of our server in only a few minutes. With Sentilla's software continuously tracking energy consumption, server profiles can be inferred over time from simply monitoring energy activity. But what's the takeaway? Every server has a unique energy profile. By measuring and analyzing energy information from each server, you gain valuable insight into how much work it is doing and whether it is operating efficiently. If we look at all the servers in a data center, we can now make much better decisions about where, when, and how to run our applications to save energy. For more information, go to Sentilla.com.